So let us get straight down to another business. There's a new business I want to show you about. Snap. The new business is this. Quickly. Is that I want to find probability. I want to find probability. Okay. Now I'm like, this is statistics. This is probability. What are you doing? We call this, under the statistics, there's a part we're going towards actually, and this part is called probability distribution. Okay, probability distribution, but I gotta call it statistics, okay, because it's part of statistics. It is statistics. Statistics is probability. You don't want to mess that all up. So in this way, what am I going to do? What am I going to do here? What I will do here is basically simple. Okay, so let's get to it. I'm going to do this. I want to calculate the probability of what I have here. So do not forget the formula for probability. So I'm going to take you back to secondary school days now. Okay, so you guys pay attention. The probability that something is going to happen equal to the number of required outcome divided by the number of total outcome. Okay, this is the formula for calculating probability. The number of required outcome divided by the number of total outcome. Basic, simple. Is that good? Now, I will explain this. Okay, take you 2 steps back. The probability that, let me assume that, okay, let's assume we have this. We say that we have some balls. We have a blue ball, we have a red ball, and then we have a black ball. Okay, so this one should have been a blue ball, a blue ball, a red ball, and a black ball. Okay, so let's assume I have a total number of blue ball to be 4. The number of red ball that I have, let's say, is 5. And then let's say the number of black ball that I have, let's say it is let's just say I have 1. Okay, just to make this simple and calm. Now, here's a question. You now ask me, what is the probability that, now I put these balls in a sack. Okay, I decide to put these balls in a sack. So let's create a sack. Okay, so let's create a sack to put our balls. Okay, so we put our blue balls, then we'll put our red balls, then we put our black ball. So we put our balls in this sack. Now from here, someone decides to dip his hand inside this sack to select a ball. I dip my hand inside this sack to select a ball. What I'm doing here, after shaking up the ball, I dip my hand inside the sack to select a ball. In this case, I will say at random. Now, what does the word random means? It means, think about it, I'm not carefully selecting it. It's different from it's on a table and I just I'm weighing it to see, is this blue, is this black, is this that. I don't know which is blue. I just dip my hand in it and then I bring out the ball. So I could bring out a blue ball, I could bring out a black ball, I could bring out a red ball, and many more. Right? So in this way, the question I have here is, what is the probability that I will select a blue ball? So in that way, we go to the formula straight away. What's the formula? Number of required outcome. What is the required ball I'm talking about? Blue ball. How many blue ball do we have? 4. The required. 4. So in that way, it will be 4 divided by total number of outcome, number of possible outcome. You can also call this the number of possible outcome. I'll break this down for you. You can also say possible outcome, the number of what is the number of possible outcome here? If you look at it, the number of possible outcome is 4, because I just said the probability of selecting a blue ball. So what I'm going to do here, I'm going to say probability of selecting a blue ball. So probability of X equal to blue, that will give me 4, because that's the required outcome, or possible number is what? 4. What is the total number? If you calculate the total number here, it will be how many? 10. So 4 over 10, which if you break it down, you'll get 2 over 5. You can ask me, what is the probability of selecting a red ball? And the probability I'm going to pick red ball out of that bag is going to be how many? The possible is what? 5. The total is what? 10. And if you do this, you get 1 over 2. What is the probability of selecting a black ball? The probability that I'm going to bring a black ball is what? 1 over how many? 10, which is still 1 over 10. Now, if you add up all of this probability that I've gotten here, if you sum it all up, 2 over 5 plus 1 over 2 plus 1 over 10, if you add it all up, your end point is going to be 1. So in this way, what I've summed up here, don't forget that each of these things I carried out here, I'm showing you a principle here, so you guys will know. So each of the things I carried out here, is probability of X, where X could be blue, red, black, it could be anything. Is that not? That's everything I carried out here. And in this way here, what do? I sum it up. When I sum up all the probability, I got 1. Sum. This is the symbol for sum. Did you see here? You get 1. So the summation of all your probability cannot be more than 1. So the summation of all your probability figure is always going to be equal to 1. When you sum out the probability of these are all the things that can happen in this event that I have here. In this event, the total thing that can happen in this event is what I've put out here. That's the total thing that can happen. It's either I select a blue ball, a red ball, or a black ball. There's nothing else that can happen. If I dip my hand in it, it's either it is blue, red, or black. But when you sum up every possible thing that can happen in this event, it must give you 1. It must give you 1. So this summation of probability of all the events that can happen, is going to be 1. Does this make sense now? Summation of your probability will give you 1. Now, that being said, that gives us an idea of what probability is, right? We'll step a little bit out of the box now, right? Now, I'll take you back to my previous question. Okay? Now, walk you back to this question, which is this question here. Pay attention now. Now, in this one, we used to call it probability distribution. This is what we call probability distribution, or frequency distribution of probability. Yeah, frequency distribution of probability is what we are going to call something like this. Okay, frequency distribution of probability. We do this in secondary school very, very well in our colleges. Now, how do this work? How this work is so efficient is that I'm going to say, if I am to walk into a house, what is the probability? If I'm to walk, we carry out this sample. If you remember, this sample we carried out on 20 different houses, and in fact, that is our summation F, 20. Is that not? If you didn't watch the previous video, I would say you go watch the first video where I talked about how this sample come about. Okay, you can go ahead and watch the previous video. In that video,